the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello, welcome back to another learning section on this platform. Today we'll be talking on the topic called fluids. In other words, fluids at rest and in motion. At the end of this lesson, we expect that students should be able to understand surface tension, adhesion, cohesion, and capillarity. Now let's talk about the fundamental law that governs fluids in motion and at rest, which is called Hooke's law. Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E is proportional to the load or the applied force. So to represent this mathematically, we say F, which is the applied force, is proportional to the extension, and then we're going to finish that. We have it to be F equals to KE, where K is the elastic constant of stiffness, which has its SI unit to be Nm, and the extension is what, in meters. Now let's talk about Young modulus. We say Young modulus E is defined as what? The ratio of tensile stress to tensile strain. The ratio of tensile stress to tensile strain, and also tensile stress is refers to what? The applied force over what the surface what area. Tensile strain is also referred to the extension E, the ratio of the extension E to what? The original length, that is L0. And the capital letter E is also used to refer to Young modulus. Now let's look at an example that portrays what we just said. If a force of 100 Newton, that is F, stretches a spring by 0.1 meter, find the elastic constant. You know the elastic constant is what? K. So if we are going to solve using the expression for Hooke's law, which is F equals to KE, we'll have it to substituting your answer. You have K to be what? 1000 Newton per meter. Now let's look at work done on the spring and also on an elastic spring. Work done is when an elastic material is stretched or compressed. You know, when we're talking about work in work, energy, and power, we refer to work as when a force moves the body through a certain distance in the direction of the force. Same thing applies here when the string is being stretched or applied, and then it is moved from through a certain distance in the direction of the force. Now the expression for that is half KE squared, and the SI unit of work, which we all know is in joules, and E, the extension, is in meter, and K, the elastic constant, is in Newton per meter. Now let's look at example 2. We say if the spring has a stiffness of 950 Newton per meter, what work will be done in extending the spring by 60 millimeter? What work will be done in extending the spring by 60 millimeter? We say W equals to half KE squared, and W, if you substitute our answer, we have half times 950 times 60 over 1000 all squared. To solve this with your calculator, you have it to be 1.7 joule. 1.7 joule. Now let's look at elastic potential energy. Elastic potential energy. Potential here talks about the ability to do. Elastic potential energy is the ability of the stretch or the elastic compressed elastic material to do work. And we have the expression to be half W equals to half E, W equals to half FE, and W equals to half KE squared. Now let's look at an example that portrays that a spiral spring is compressed by 0.02 meter. Calculate the energy stored in the spring if the applied force is 400 Newton. Since we know we are being given F and E, so the formula we're going to use is the first term, which is half Fe. Or if we're given K and E, we'll use half KE squared. Since we're given f and e, the parameters in the question, so we substitute our answers, our values for f and e, and we solve. The arithmetic will have to be w equals to 4 joules. Will you be able to understand something from today's lesson? Here's a little assignment to just help you reinforce what we've learned today. If a force of 100 newtons stretches the spring by 0.1 centimeter, find 1. The elastic constraint and the work done in stretching the spring 0.3 centimeter if the elastic limit is not exceeded. You understand that? E is in meter, so you have to convert from centimeter to meter. Thank you for your time, and do have a good day, and see you in the next class.